Welcome back, everybody, to another deep dive. This time, we're taking a look at the very top AI research papers of 2024.
Ooh, exciting.
As chosen by the ICLR Outstanding Paper Awards.
Yeah, think of ICLR kind of like the Oscars, but for AI research.
Oh, yeah.
So, getting one of these awards here, it's a really, really big deal.
Huge deal.
It is a huge deal.
For sure.
Yeah, these awards really represent the absolute best of the best in AI innovation.
Yeah.
They're really carefully selected for their potential to impact the world.
Right.
And the selection process itself is incredibly rigorous.
Well, yeah, I bet.
You have all the top experts in the field, poring over hundreds of submissions, debating, which ones are really truly pushing the boundaries of AI.
It's not just a flashy demo. It's got to have real substance.
Right, exactly.
Power to change things.
Okay, so the first outstanding paper is titled Generalization in Diffusion Models Arises from Geometry Adaptive Harmonic Representations.
Oh.
Now, before you tune out thinking this is like a physics lecture,
I know, right?
I promise it's super cool.
Okay.
This paper is all about how those AI image generators that everyone's obsessed with, how are they able to create totally brand new images?
Yeah.
Instead of just spitting out slightly older copies of stuff they've already seen.
That's what I've always wondered, how do they go from copying to creating?
Right.
The difference between tracing a drawing and actually painting your own unique masterpiece.
They use concepts from something called harmonic analysis, which is a way of breaking down complex patterns into simpler components. Yeah. So think of it this way. The AI isn't just seeing pixels. Right. It's understanding the underlying structure of the image.
Oh, wow.
Which lets it create something truly new. Okay, let's move on to learning interactive real-world simulators.
Okay.
This paper takes us into the world of robotics with a project called Unisim.
Unisim. I'm picturing some super advanced simulator, something straight out of sci-fi.
You're not far off.
Okay.
Unisim is all about training robots in virtual environments that are as close to the real world as possible.
Wow.
And what's really cool is that it does this by combining information from a bunch of different robot types.
Oh, wow.
They figured out how to blend visual data with textual descriptions to create these incredibly realistic training grounds.
So instead of training a robot for one specific task,
right,
like picking up a box in a warehouse, you could train it for a whole bunch of scenarios.
Exactly, and it can learn from the experiences of other robots.
Oh, wow.
Which is huge for developing robots that can adapt to new situations and environments.
Wow.
Imagine robots that can help out in disaster zones or explore unknown planets. This is the kind of potential we're talking about.
Now that's what I call pushing the boundaries. All right, give me another mind-blowing AI breakthrough.
In a way, yes. This paper focuses on long sequence models, which are AI models that are really good at processing long strings of information.
Okay.
Like text or time series data.
Got it.
So imagine trying to summarize a whole book or predict stock market trends. That's the kind of thing these models excel at.
Okay, I'm with you, but what does never train from scratch have to do with these long sequence models?
Well, the researchers found that even the most advanced models, they get a huge boost in performance when they have access to some pre-existing knowledge.
Oh, interesting.
They call this data-driven priors, which basically means giving the model a head start by feeding it some general knowledge about the world before training it on a specific task.
So it's like giving someone a basic understanding of grammar before asking them to write a novel. It just makes the whole process more efficient.
All right, this next one is protein discovery with discrete walk-jump sampling. And it's a fantastic example of AI being used to tackle real-world challenges in science.
Oh, okay.
We're talking about AI designing antibodies.
Whoa, AI designing antibodies. That sounds like science fiction. How does that even work?
They took the AI-designed antibodies and tested them in real-world experiments.
Oh, wow.
And guess what?
What?
They worked.
No way.
This last one is fascinating because it reveals a kind of blind spot in a very popular type of AI model called vision transformers.
Okay.
The paper is titled, Vision Transformers Need Registers.
Vision transformers. Remind me, what are those again?
Think of vision transformers as the eyes of AI.
Okay.
They're designed to understand and interpret images, and they're incredibly good at it.
Okay. Did they figure out how to fix it?
Yeah.
I mean, we don't want AI missing the main event because it's too focused on the scenery?
Exactly, they did. And their solution is surprisingly simple.
Okay.
They introduced something called register tokens into the model.
Register tokens are those like attention grabbers for the AI? Oh, hold on, we haven't even talked about the honorable mentions yet.
Oh, that's right.
And I'm betting those papers are packed with equally fascinating discoveries.
You're absolutely right. There are 11 honorable mentions this year,
Wow.
covering a huge range of topics to give you a taste. We have papers exploring how to make large language models more efficient, how to use AI for strategic decision-making, and even how to ensure the fairness and reliability of AI models. This one takes us back to the world of robots,
Okay.
but with a pretty fascinating twist.
Okay.
The paper is called Robust Agents Learn Causal World Models, and it's all about teaching robots to think more like humans.
Hold on, robots thinking like humans? Isn't that the stuff of science fiction?
Right.
Last time I checked, my Roomba wasn't exactly writing poetry or pondering the meaning of life.
Probably not poetry, but
Okay.
this research is taking a big step towards robots that can understand cause and effect.
Oh, wow.
Instead of just blindly following instructions.
Yeah.
These robots are learning to reason about why things happen in their environment.
It's like the difference between memorizing a recipe
Yeah.
and actually understanding the chemistry of baking.
Right.
If you know why ingredients work together,
Right.
you can adapt the recipe, troubleshoot problems, and even invent new dishes.
That's a great analogy.
Yeah.
And that's what makes this research so exciting.
Yeah.
We're not just talking about robots that can perform pre-programmed tasks.
Right.
We're talking about robots that can learn from their experiences, adapt to new situations,
Wow.
and even solve problems they've never encountered before.
Okay.
The robots essentially learn through trial and error, figuring out which actions lead to the desired results.
So it's like giving a dog a treat when it fetches the ball.
Exactly.
Over time, the dog learns that certain actions lead to positive outcomes.
Exactly. And just like a dog can learn to fetch different objects,
Yeah.
or even navigate obstacles to get to the ball,
Right.
these robots are building up a more sophisticated understanding of how their actions influence the world around them.
In all its complexity, what are some of the hurdles researchers are facing?
Well, one of the biggest challenges is the sheer complexity of the real world.
Yeah.
It's one thing to train a robot in a controlled lab environment, but it's a whole other ballgame to have it operate in the real world with all its unpredictable variables and chaotic scenarios.
I can see that it's like the difference between playing chess against a computer and navigating rush hour traffic.
Right.
The real world throws you curveballs you can't always anticipate.
Exactly.
But speaking of data, let's shift gears a bit and talk about those massive language models that seem to be taking over the world.
Okay, yeah.
I'm curious to hear what research stood out in that area.
You're talking about those large language models, LLMs,
Yeah.
that can generate human quality text, translate languages,
Yeah?
even write different kinds of creative content.
Yeah, those things are mind-blowing.
They're a hot topic in AI.
Yeah.
And this year's awards highlighted some fascinating work in that area. Sure, imagine these large language models like giant libraries filled with information.
Got it.
They need to access all that information to generate text and complete tasks.
Okay.
But it can be very computationally expensive to process all that data.
So it's like trying to find a specific book in a massive library without a good cataloging system.
Yeah.
It would take forever to search through all those shelves.
Exactly.
Yeah.
So this paper proposes a way to compress the information stored in the model's memory,
Okay.
making it much more efficient to access and process. Speaking of democratizing AI,
Yeah.
another honorable mention paper tackled the challenge of training AI models with less labeled data.
Oh, okay.
It's called Towards the Statistical Theory of Data Selection Under Weak Supervision.
Weak supervision. That sounds intriguing. Is that like training an AI with cliff notes instead of the full textbook?
It's a bit like that in traditional AI training. We need tons of data that's been carefully labeled.
Right.
Think of it like teaching a child to recognize objects by showing them flashcards with pictures and words.
Yeah.
But labeling all that data is incredibly time-consuming and expensive.
Yeah.
But let's not forget about the ethical implications of all this.
Oh, yeah, that's a good point.
As AI becomes more powerful and pervasive, we need to ensure that it's being used responsibly.
That's a crucial point.
Yeah.
And speaking of responsibility, I'm curious to hear about any research that addresses the potential downsides of AI. Is that even possible?
It's more nuanced than that. LLMs are incredibly good at generating human quality text,
Uh-huh.
but they're still essentially probabilistic machines. They're making predictions based on the data they've been trained on.
Yeah.
And there's always a degree of uncertainty in those predictions.
So even if the AI sounds confident, there's a chance it could be wrong.
Right. Tackled a rather sensitive issue in the field of AI.
Okay.
Test set contamination.
Test set contamination, that sounds like a scandal waiting to happen. What exactly are we talking about here?
It's actually a pretty serious issue.
Okay.
Imagine you're taking a test and you've already seen the answers beforehand.
So it's like the AI has already seen the test questions before, so it knows the answers?
Right.
That doesn't sound very fair or accurate. How do researchers even detect this contamination?
It seems tricky to catch an AI cheating.
It's definitely challenging, but this paper, Proving Test Set Contamination in Black Box Language Models, introduces a method that can identify contamination without needing access to the model's internal workings.
So they've developed a way to catch AI cheaters even if we don't know exactly how they're cheating. That's impressive.
Exactly.
This is giving me a lot to think about, but before we go too deep down the rabbit hole of AI ethics,
Okay.
let's shift gears again and explore some of the more whimsical areas of AI research.
What about AI and creativity? Were there any papers that explored how AI is pushing the boundaries of art, music, or storytelling?
Absolutely. There were a couple of honorable mentions that delved into the intersection of AI and creativity. It's a bit more technical than that,
Okay.
but it involves training AI models to understand the underlying structure of complex data, and then using that understanding to generate new original content that follows the same rules.
Okay.
It's like teaching an AI to speak a new language,
Yeah.
and then asking it to write a poem in that language.
So it's not just about imitation, it's about giving the AI the tools to express itself in a creative way. That's fascinating.
It is really cool.
But we're running out of time for this part of our deep dive.
There's one honorable mention paper that I think beautifully illustrates the power of AI to learn from unexpected sources.
Okay.
It's titled, Is ImageNet Worth One Video? Learning Strong Image Encoders from One Long Unlabeled Video.
ImageNet, that rings a bell. Isn't that a massive data set of labeled images that's been used to train a ton of computer vision models?
You're exactly right. ImageNet has been a cornerstone of computer vision research. But this paper asks a pretty provocative question.
So instead of carefully curated pictures of objects, they're using videos that capture a more natural and holistic view of the world.
Exactly. And what they found is that these walking tours videos provide a surprisingly rich source of information for training AI models. The model has to learn to track objects as they move through the frame deal, with changes in lighting and perspective, and even understand the context of the scene.
It's almost like the AI is learning by experiencing the world through someone else's eyes.
And that brings us to another fascinating theme that emerged from this year's awards, the idea of AI models learning from limited data.
We touched on this earlier with weak supervision, which is all about training AI models with less labeled data. Are there other approaches that researchers are exploring in this area?
Absolutely. One honorable mention paper that caught my eye is titled The Mechanistic Basis of Data Dependence and Abrupt Learning in an In-Context Classification Task.
Okay.
This paper delves into a fascinating phenomenon called in-context learning. This paper specifically focuses on understanding the underlying mechanisms behind in-context learning.
Okay.
The researchers conducted experiments on simplified data sets and found that certain distributional properties in language play a crucial role in enabling this type of learning.
Distributional properties, can you give me an example of what you mean?
Think about how certain words tend to appear together in a text. For example, if you're reading an article about astronomy, you're more likely to see words like stars, planets, and galaxy appearing together frequently.